this is the smallest water bottle I've ever seen. Like, why would you sell? Is this like just a swig of water? I don't know. Like,
It's
anyway,
very small.
um, anyway, good morning, good afternoon, good evening, good whatever you are joining us from. Welcome to episode, say it again, 14 of Build On Weekly. This is a weekly live show where the wonderful Jackie and I get to meet our wonderful guests every week. Well, almost every week, where we talk about the cloud, open source, the community, technology, and everything in between. Today is October 20th, 2022. And on episode 14, we're going to have a wonderful time with the wonderful Shana Schipers here, who's going to be talking to us all about an open source project called Apache HUDI. All things you need to know about managing data in a big old data lake with that and a few other things. I don't know plenty about it, but Shana will be able to explain all of that to us. Speaking of that, Shana, tell us who you are and what you do.
All right. So yeah, Shana Schipers. I am a specialist SA in analytics at AWS, and I focus mainly on big data. So that means anything, EMR, Glue, but also cool open source frameworks like Apache HUDI, for example. Love those. So yeah, my role is really helping customers with, these kind of technologies. I'm based out of Belgium, part of the EMEA team, and that's about it.
Awesome. So tell me one best thing about Belgium.
Oh, easy. Fries. People think it's
Fries.
French. It's not. It's really not.
Yes. Yes, exactly. Don't call fries French
Yeah.
fries. They're Belgian fries.
Yeah.
And that's actually a weird story because apparently it was invented by Americans. Well, the name was invented by Americans because they saw them in Belgium and people spoke French in Belgium. So
Oh, that explains. Yeah.
yeah.
But somehow people think it's French, but it's the best Belgian thing.
Yeah. Do you put mayonnaise on your French fries?
Oh yeah, totally.
Exactly.
Yeah.
Yes, exactly. Flemish, as somebody would say, Pondo 86, Flemish fries, right?
Oh yeah.
Awesome, Shana. Thank you so much for joining us. By the way, we had Shana before on one of our shows. It was Build On Data and Analytics. If you want to go check that out, we have a video with her somewhere on YouTube. I'm going to post a link in the chat as well of that video before. So Shana is not a new person on this type of format, and we're going to be covering something Apache HUDI, something big data today. Before we get into that, hello chat. How are you doing? Are you okay? How's your Thursday treating you? Are we audible? Is our sound okay? I want to make sure that's all good. And also, is there anybody
to be asking?
Yeah. Is
As
there
I jump
anybody
in,
else
be like, is my sound broken?
Yeah. So also, is anybody else from Belgium joining us, or is Shana the only person here? So
Oh, that would be cool.
yeah. If there's anybody
No,
from Belgium,
we're a
say
tiny
hi.
country, so we're usually not that many.
That's okay. I think you're the third Belgian I know in my life. So there you go.
Whoa. We're well connected.
Awesome. So let's slowly kick it off. Shana, first of all, let's explain why Apache HUDI. Why do we have a need? First of all, no. Let's tell me what problem we're trying to solve before even talking about Apache HUDI. What problem are we trying to solve?
Okay, let's start there. Let me ask you a question. Have you, or the audience even, have you ever tried to delete a single record from a data lake on S3 or any other one, really?
I have not,
easy,
but
right? So
it's not easy.
Seems like a very easy thing to do. You're like, oh, delete a single record, just like in a database. But it's not, because then you have to go figure out what file that record is in. And how do you find that? In Data Lake, you have a ton of data, massive amounts of data, and start scanning it, right? So it's very tough, very slow, very expensive to do. So that is one of the problems that HUDI solves. Another one is, have you another problem that customers, everyone really experiences, is real-time streaming into data lake. It's awesome, right? You get your data in real time in the data lake. You can run real time analytics. It's great. The only thing is, how do you manage that? Because you get tiny bits of data, constantly flowing in. You end up with these tiny, tiny files, but massive amount of files. If you start reading that from the read side, it's going to be terribly slow.
Yeah.
So that is another thing that Apache HUDI helps you solve, and many other things really. But those are some important ones I think we could start from as challenges that were that made us look into
Yeah.
HUDI and others in the first place.
So I think we have
Okay.
a
So
couple of responses to our first question there about whether people have tried to delete a single record. I just want to pop those up. From Brooklyn, we had from Brooklyn. I can't. From Brooke. Sorry, Brooke. You said New York earlier, and now I'm done. But it sounds fine, but it's usually not fine.
Yeah,
And then
exactly. Also, how do you know it succeeded, right? So if you then delete it, and you basically have to open a file, delete the record in memory, and then rewrite that file back to S3, that entire file. But how do you even know like it succeeded? Like data quality issues and all that are easy to get into with data lakes. So even if it sounds fine, it's sometimes not fine, and you might
yeah,
not know.
absolutely. And we have superfan Kevin here saying that deleting a single record from a data lake is like using that small water bowl to bottle to scoop water out of a real lake. And I mean, I think one of the issues we're trying to solve here, because of course data lakes have a lot of data, right? That's their purpose. You just dump all data into it, and sometimes actually accessing individual bits of data can be difficult, confusing, and sometimes not even successful, right? So I think this is what HUDI is trying to solve for us in part.
Yeah. And so, like before, when HUDI was not around, so for example, people often use a Hive catalog, right, or Glue data catalog, and so you have a list of what data you have in the sense
Yeah,
that you know your folders or partition paths, and you know what files you have, but that's about it. Once
yeah,
you don't know what is in the files, which file contains what kind of data, that kind of stuff was missing. And so when you really go to large scale data lakes, that becomes an issue to find things back in there,
yeah,
both for reads, but also for updating or deleting then that data. Because we have these in S3, for example, we have we have immutable objects, right? So there's
right,
no update functionality. It's read and then rewrite the whole thing, which is
exactly.
also not very cost efficient. Another thing that HUDI solves, by the way, by
Yeah,
adding your
okay,
updates next to your files as a separate object related to it.
yeah,
Very cool. Allows for fast
okay.
write. Great for streaming.
That is pretty interesting. Now, maybe a comment here. Maybe we can take a step back and just explain why would I, Darko, use a data lake? What's the deal with data lakes? I mean, we think it's common knowledge, but why would I use a data lake? Why would I store such data or whatever?
Yeah, absolutely. So yeah, previously, like 10 years ago, it was only databases out there because we only had that technology and it was great.
Yeah,
But what you run into with the data lake, sorry, with the database, for example, easily is okay, how can you analyze that data in there? Well, you only have also that one tool, right? So you can run SQL queries on it, for example. That's about it. How much can you do with SQL? So nowadays we want like real insights. We want to forecast things. We want to run machine learning on our data to get
yeah,
like more valuable insights. We want to combine different sources, and that is like what a data lake is ideal for because you can store data in open formats. For example, in Apache HUDI as well, it uses open formats, and then you don't have even like a use case for that data yet today, but this data might be valuable in the future, so I'm going to store it, and then when a use case comes along that you could get insights from that data, you start analyzing it with the tool of choice. And as really decoupling that storage from the compute which you use to analyze it. And that, gives you a lot of opportunities to, yeah, in terms of like analyzing your data, but also to store your data much, much cheaper and at larger scale in data lakes.
yeah.
I feel like that's the first time that I've really felt click why I would use a data lake. So
Oh,
I've
thank
heard it a
you.
lot and I'm like, that's cool, but I don't know why I would do it or what it is or really much.
Yeah.
Data is not my area of expertise. So I'm just kind of like, I trust the data people, but
Oh,
I
I'm
don't
glad.
know why we're doing that. So
Awesome.
Yeah, that was awesome. Thank you.
So a question for the audience. Do you use data lakes? Do you have data lakes in your organizations? And when is the first time you saw a data lake? The first time I saw a data lake was like maybe only like 6, 7 years ago. In a company I used to work for. Before that, I never had any interactions with data lakes. In my head, it was like, oh, I just store data in a database. But that turns out to be expensive,
Yeah.
especially with the vast amounts of data that we have today. And I think that's also a very important thing to point out to all the folks here. 10 years ago, we had way less data, right? There was not as much data being consumed and used as we do today, just because of so many different things. We talk about observability, we talk about logging, we talk about user experiences, click streams, whatnot. All of those things go into some data lake now to be done something with, right? So, yeah. Awesome. So, Shana, let's talk about Apache HUDI. What does HUDI do? Or if Kevin says hoodie, like a little actual hoodie, HOODI.
Yeah, actually, that is how they usually write it in the code. So that is a funny thing, right? So the name is hoodie with a U, but always when you see the code, it's all hoodie double O.
Hoodie.
Yeah, special.
Does hoodie stand for something, or is it just
Yeah.
named hoodie?
Hoodie stands for, and now bear with me here, Hadoop, upserts, deletes, and incremental, I think. So for doing upserts, deletes, and like incremental queries on your data lake, asking your data lake, tell me what has changed since that time.
Okay.
Which is
Okay.
also,
I love that.
yeah.
I love it.
So what is hoodie, right? So we do have a common understanding of a data lake now, right? Because I explained that
We
so
do.
well.
We do. Yes. You
So,
did.
so once you have the data lake, so you have all these objects sitting in S3. And actually, can we bring up my screen so I can like talk to something rather than just
Yes.
people
Yes.
watching my
There you
face
go.
when I talk about data lakes.
There we go.
So let me just open S3, and I'm like the messy type of person, so bear with me here.
Shana, can you just slightly zoom in so we can see this thing a
Oh,
bit better?
totally.
Thank you.
So let me just like open whatever. I think, for example, one of my testing. Let me see what. Yeah, of course that happens. I open one with just one file. But let me just open another one that I know has more in it.
Yeah. Yeah.
So for
Shana
example,
will look for a database. Okay. For a
I like
data.
that it all says hoodie here, as we were just talking about too.
sorry, I was not following. What?
Oh, I like that all these files say hoodie, as we were just talking about too.
Oh
With
yeah,
the double O spelling.
Okay, so but this is Parquet. So before we, yeah, I know. I pulled up hoodie already. Anyway, so if we talk about like a data lake, so this is it, right? So we have Amazon S3, and we have a bunch of data sitting in there in folders. So if you now ask like what is hoodie, then you know, and how do I start that? Well, hoodie really starts just from your data on your data lake on S3, for example, like you have here, Parquet files. But what hoodie would do is to add additional, metadata on top of that data. And for example, it looks like this, and that tracks like all the changes that were made to your data over time. Every single action that happened on your data is tracked over time, as well as like some additional metadata that it adds, like you can compare it to an index in a database, allowing you to easily find back, for example, where which of these files contains, in this case it's patient data, a certain patient with a certain SSN, for example. So hoodie adds, like, you have your data on your data lake still as just objects in Parquet, but it adds an index on top of it, and it adds a timeline of all your actions. And with these two things, like, hoodie allows you to then go ahead and do updates easily, delete things, like delete certain records easily, but also like manage file sizes and all that. We can go later into detail, but really that's just it, right? So we're not running a hoodie server or anything. It's not a runtime engine. It's just, additional layer of data, metadata on top of our data lake. And that's really it.
So my understanding is that hoodie doesn't do anything with data necessarily. It just keeps track of data, right? Is that a correct thing? It keeps track of what we've done with the data, like.
Yeah, it keeps track of everything you've done with the data. So that's in a .hudi folder that it adds, together with your data. So this, all the actions that were taken.
Okay.
But it also, and let me show you this, it also actually adds some data to your data. And let me pull up. So to track what data you have, so I have here my patient's data. See, so I have my fields. Can you see that, by the way?
Yes.
Yeah. So I have my fields of my data that is just containing my data, my patient records here. But see these dash commit time, dash sequence number, record key partition path, file name.
Yeah.
This is some metadata that HUDI adds to every single record, and I'll show you what that looks like. To keep track of what file contains what record, really giving you that index.
Yeah.
So if I show you from this patients table, you'll see at this time it was committed, allowing HUDI to know exactly, what happened at a certain time. So if you say, show me the table or my data 3 days ago, what it looked like, you can also do that, and it can easily roll it back that way. You have a key, and then the file that contains, that specific record for Jimmy. And by the way, this is made up data. It's just not data. But yeah, so it does these two things of information. It really adds to your data, and that allows it to implement all of its functionality in terms of upserts, in terms of deletes, in terms of reading and easily finding specific patient back in that record, in those files, things like that.
Okay, a question here. A non-English speaker. What is an upsert?
I definitely just Googled that as soon as you said that. I was like, what is this? So that's a great question.
What's an upsert?
So an upsert is actually an update or an insert. And what I mean is that a record comes in and you say, upsert this into my data set. What then will happen is that you check whether that record with that key, like a primary key in a database, if you will, already exists. If it does not, then it adds the data, the new record as an insert, and just adds a new record. If it does exist already, that primary key, if you will, then it goes ahead and updates that existing record. So you don't have duplicates in your data set. So that's also a really awesome feature in data lakes, because generally you don't have deduplication. But with HUDI's upsert functionality, it will always check like, oh, does this exist or not? Do I need to update or do I need to add a new record? And so you never have duplicates that way.
Yeah. Today I learned. I did not know of a word called upsert. I mean, it makes perfect sense.
Today I learned is already like 4 things deep. This
is great. So Rando 888, it's like insert, but it doesn't just insert. So if a record already exists, it updates it instead of creating a new one for it, right?
Yeah.
And does upserting work with like immutable data lakes? Like what will it do if a data lake is immutable?
So it will just rewrite your file. Now, there we can, and I won't go too deep into the HUDI technicalities here. But what would happen if I show you this again? Oops, sorry. Let me go back to the actual data of the patient. So let's say, we're updating a patient that sits in this file.
Okay.
What would happen is that we're actually going to create a new version of this file. So we leave this file here, but we add another one that is a duplicate of this, but has either the updated record for that patient or a new record that we added. This is one type of functionality. Like, you have the multiple versions. You could tell me you're still rewriting. That's true. But we're doing that. We're leaving this version so people can also continue to read while we're writing, and that's also an important thing, right? So usually on data lakes, let's say I'm like rewriting this file and at the same time someone else is reading this. How do we know what kind of view they'll have on the data? Maybe they see partially what I updated already, partially the old version. We don't know. But with HUDI, like keeping like just this version, this file as V0, let's say, and just updating by adding a version to it, we get people just continue to read from this older version, and while we create a new one, and we get like, no conflicts there. But then again, like to update, we're going to rewrite this. If you say that is too slow, we can look at other HUDI options like different HUDI table type that would actually just add a log record here together with my Parquet file, and that is faster. But that's another table type. It's a HUDI option.
Yeah. So just stopping here for a second. We talk about data lakes and now the speed of changes and everything. Asking a philosophical question now, how important is the speed of updates in a data lake, right? How critical is that? I know like on a database it should be critical, but on a data lake, is that so critical that people need to worry about?
Yeah, as always, it depends, right? So depending on your use case, it might or might not be important. So let's say I have, for example, here let's take the patient data as example. For example, usually this data is coming from databases that we have in old on-premises systems, where people still add the patients in every day. And we might even load that on like a nightly basis into our data lake because we don't need that data real time. Then it doesn't really matter to us how fast this update is, if that takes 1 hour or if it takes 2 minutes, because we're going to do that as a nightly batch process. Now, if we have real-time streaming data coming in that we also want to analyze in real time, for example, let's say we have like smart meter data, and we get that energy reading in real time, and we really want to like analyze energy or like electricity utilization in real time to also encourage people to adjust their behavior accordingly. Then the real time is really important. And so if updates come into that data, we want to make sure that as fast as possible that is reflected, so that all the downstream analysis and insights also reflect the correct view. So as always, it depends, and you can make that trade-off, right? So you can design differently depending on whether that is important or not.
So in essence, basically, a data lake is not necessarily just data which can be analyzed later on, but it can actually be used in real time if you have a use case. Now, today I learned that a data lake is a thing you throw different formats of data, different sources, not formats, different sources of data. You can just do stuff with it, right? So like you can do real-time data like, I don't know, gas, network, power usage, whatever, and you can do stuff with it. But you can also use some user experience data, which just goes into a data lake and can be analyzed at a later date. Hence,
I feel like Chris just gave us like a really cool example in chat here. He said he's totally got monitoring of power consumption in his home, and it gives him near real-time usage analysis, which is really cool to figure out new ways to save money. And I'm liking this whole discussion, just making everything click into place for me better. So I'm really enjoying this.
But here's the thing.
Oh, sorry, go ahead.
Just to add a thing here for the folks out there not using data lakes. So if you have a single data source like Chris has, like just power meters, that's fine. That's it. You can actually use it from a single database. It's not expensive. It's not complicated. But imagine having thousands of people having power meters with potentially different data sources coming from them. Instead of just using multiple different databases and collating that data somehow weirdly, you just dump all of that data. You stream that data in a data lake and do something with it. Is that the correct assumption, Shana?
Yeah, totally. And I was about to ask because I recently actually did a demo on this energy use case, streaming data into a HUDI table on the street. So I can also show you if you want.
Yeah.
In the meantime, feel free to
that's really cool.
Continue. Let me just like quickly before I start data generation, I'm going to see, I even prepared this like nicely for a demo. You can see that. So I'm going to restart it. And this is like just a Jupyter notebook running on EMR. And so I had my pre-demo setup hidden to hide the complexity a little bit of what I did, because I really tried to optimize, performance and all that to get really fast, right? So my Spark application is starting now. But in the meantime, what I also then created is, and I'll show that, I ingested data, like fake data for this type of smart meter. So I created a producer just sending, for each customer every, I think, few minutes I send it an energy reading like kilowatt hours, and I stream that into my Hoodie table. So I'll just run this. It's just like tiny little Python thing that I wrote. It's not something fancy, but it does a trick of showing you this. So I'll run that to get my data running.
For this, can we just zoom in a little bit more?
Yeah, absolutely.
Thank you.
This is nothing special, just my data running.
Every code is special. Every code is special, Shana.
Okay, yeah.
But while this is executing, can I ask you a question now, just to kind of demystify a bit of this? Does Hoodie have a front end? Where's Hoodie running? Is it running on your computer? Is it running on an EC2 instance? What?
I'll show you right now. So what I have now, for example, is just I have a Spark session. And so really what I do is sorry, let me just unhide that, is I load a Hoodie dependency package into my EMR. And so I can use Glue, I can use EMR and just point to this Hoodie jar. And then I can start, using Spark to read and write to Hoodie. So we don't have Hoodie running, if you will.
Yeah.
It's just,
What is Spark? What is Spark for all the people out there?
Oh, that is a tough one to explain. Darko, you put me on the spot here.
If anybody can explain, it's you.
What?
If anybody can explain, that's you.
Yeah, but to put it in simple terms, it's actually like distributed compute engine, if you will, or processing framework, if you will, to really like process data, not just one file in one computer, but split that file up and oversimplifying this, split that file up in multiple small chunks and have like 5 computers processing these file chunks in parallel and doing it faster than if one had to do the whole file. That's a little bit the idea behind Spark.
And it's running either on an EMR cluster, Elastic MapReduce cluster, which is used for such things as Spark jobs, or on Amazon Glue, right?
Correct.
There we go.
Yeah.
Good. Okay. So.
All right. So we're in Spark now, right? So we're going to write Spark code, and this looks fancier than it is. I'm just going to run this. So what we do with Hoodie is like we had loaded the jar, the dependency, to be able to write to Hoodie and to read from Hoodie. And what I'm going to do then is like just some basics options. Like Hoodie needs to.
Can you zoom in on this one as well a bit so we can see? Sorry.
Yeah. So we tell Hoodie here what we want our primary key fields to be, what partition path we want to use. I'm just calling out some ones that we want to use, like that we want to like sync our table to our Glue data catalog, so we can query using Athena afterwards, for example, and things like that. Really, just like how many file versions I wanted to retain, because I told you like creates multiple file versions.
Right.
We can also have Hoodie automatically clean that up for us. So I say I just need one. So I don't want it to like keep 10 versions of the data and I'm paying to store that data if I don't need it, if I'm not going to use it. So just keep one. And then like the other options we can go into later, but it's a bit more in depth. Anyway, so I'm going to start reading now because I pushed my this nice energy data, pushed that to my Kafka topic that I have running. I didn't show you because it's a bit beyond scope today, I guess. But anyway, if all goes well, this still works, because I have to say I didn't practice this demo anymore since I delivered that. So let's hope for the best. I'm reading now from my Kafka energy topic. So this is really just streaming data coming in. As soon as I push it, which I'm constantly pushing, this is going to read my data. So now I'm going to do the same. Spark always reads into a data frame, which is really like a structured representation of your data, almost in a table format, in columns. And we can just write this to Hoodie. I'm not going to show you this. So we need to define some other Hoodie options. For example, an important one and really cool is I'm going to tell Hoodie, like, I want this as a minimum file size that you need me to get. So Hoodie will automatically, and this is in bytes, so that's like 100 megabytes here. So Hoodie will automatically, keep adding data to files that are below this size. So to get me to that 100 limit that I wanted, which is great for streaming use cases. So imagine, this data coming in, this tiny data, it's not taking up a lot of space. So we need to somehow, pack that together in a file so that it becomes a bit bigger.
Okay.
And then we're going to start the stream. So this is really nothing more but writing my data frame that I had just read, my Spark data frame, saying I want it to be written in a HUDI format to my data lake, and I'm going to point it to my location, which I'll show you in a bit. I'm going to start this. So now if all goes well, I should be getting a table. And see, we didn't actually create this table before we started. So HUDI, with the first write, it will automatically create this table for us if it didn't exist yet. So that's also
Where does it create a table?
Yeah, let me show you that actually. So I'll
Okay.
zoom in a bit. So I actually specified this path of the energy data. And so we see that this just now got created actually. So for me, it's like 1834 now. And this is my table, right? So this is the path
Yeah.
that I specified. And it starts creating like this metadata, and my data is coming in here.
Okay.
So now I'm writing to HUDI in real time. And if I refresh this, more and more objects will get created, hopefully.
Yeah. So
There you go.
while we're waiting for this one, to answer the question coming in from Ricardo here, basically, what format is HUDI using in this case?
Yeah. So good. Yeah. So good one. So HUDI writes in a combination. In this case, it's a combination of Parquet and Avro log files. But what you can do is like it uses all open formats, file formats like Parquet and Avro. So you can choose to have Parquet. Remember in the patient data use case where
Yeah.
we have a Parquet and we keep multiple versions of that. We rewrite the entire file every time.
Yeah.
But this one, for the streaming use case, I wanted faster, faster updates. So I actually created what is called a merge on read table type, a HUDI, and that creates, updates in log files. So this Parquet data file still has all my data with the energy readings, like the smart meter readings. But this one has updates to the file, to the data in this file. So if readings get updated or incorrect readings were sent and updates are sent, then this file contains the updates to that one. And that's going to be much faster.
Yeah, got it. Okay, awesome. So this data that you're streaming now, and you are streaming this, does it go through HUDI? Like, does HUDI capture it as it's being streamed? Like, I'm trying to, wrap my head around this.
Yeah, so this is really all just Spark.
Spark. Okay.
So we just like have Spark, like in any kind of Spark streaming application. So Spark streaming is like the real-time data processing or stream processing engine of Spark that you can use for real-time use cases. And so just like any other Spark streaming use case with other, if you would be streaming just to Parquet on S3, it's the same. It's the exact same thing. The only thing that changes is we need to tell Spark now that we want to write the data in HUDI format. So we do nothing more than that. And then with all these options, we know what to call our table or our path. Here is that merge on read type that I told you about.
Yeah.
And and Spark will, instructed by HUDI, really get us these file sizes that we're looking for. So it's really just any kind of like any other Spark application, but then with a different format as the target.
Beautiful. Just gonna pause here and say hello to all the new viewers joining us on stream. Hey, hello, folks. Welcome to Build On Weekly, episode 14. And today we have Shana here talking to us all about things neither Jackie nor I know. Data lakes, Spark jobs, HUDIs. I don't know. But we're learning a lot today. So
Yeah,
what
we
we're
are.
looking at we're looking at basically data being ingested by a Spark job in a HUDI format, and we can do something with it, right? So maybe that's a question for you, Shana. Now, once we have this data in, now what?
Now what? Yeah, go on. So let me go back to my data real quick. So let me refresh you. You'll see this constantly changing, right? So we have Parquet, we have log files. If we go to Athena to show you what this looks like, let me refresh, and if everything went well, yeah, we have a smart meter table. But see that we have two instead of just one now.
Okay.
And that is because of the table type that we're using. So I said I want merge on read. which means Parquet files containing data, log files containing updates to my data. Now you might say, how do you read that, right? So hence merge on read. So you have to read Parquet, read the log files and merge it, when reading. If you want to do that, what we call, then we say we have a real-time view, because if we want to know, like in this kind of data, the latest view on my data, I also need to read this, right? I cannot just ignore this, this log file containing my updates. And I can do that. And it's a read type, we still have like the same fields here, but with my energy data. And if I read this, the real-time table format, well, I cannot call it a table format, a real-time view on my data. What HUDI will do, I'm sorry, I zoomed in a little too much, is really just merge like all these Parquet files with my log files and give me that view, to give me the latest view on my data. But the drawback of that is, that merging of the Parquet file with the log file, that is a little bit slower, So if I want really, really fast queries, I can, choose to do a trade-off between how fast I can read and how fresh my data needs to be. If I say, I am actually fine with having data that is like fresh from 2 minutes ago and not having the latest updates from the last 2 minutes, I can choose to only read the Parquet files, and that is much faster. And that is like the read optimized view. Again, in table schema. But if we read this, we'll only be reading Parquet data, and that will be faster. So, this is how we can then use that, get the benefits, like the best of both worlds. We have those fast writes because we have log files, but we can still get fast reads if we want to compromise a little bit on data freshness and not have like the latest updates included in what we read.
That's amazing. I think that this is very, very useful. Now, these tables, the smart meter underscore RO and RT, these were created by that Spark job by HUDI, right?
Automatically, yeah. So I did this here. Let me show you. I said, no, not this one. This one. I said, please sing this to Hive, and my Hive catalog is my Glue data catalog, and then all of that gets handled for me. So if I would now show you, because this is now actually coming from my Glue data catalog, right? That catalog. So if I show you this in Glue, and I'll zoom
What is a Glue data catalog? What is a Glue data catalog?
A Glue data catalog is a Hive compatible metastore, and that is a mouthful, right? So it's a Hive compatible metastore in the sense that what that is supposed to do is really keep an inventory of your data in your data lake, because there's a lot in there. You put a lot in there. That's the sake of like the whole point of a data lake. But you kind of want to keep track of like what location in your data lake has what data, what format is that in, what is the schema of that data. So that is what you store in a catalog. And that's why I also say, I want my HUDI tables also in this catalog, because they're part of my data set. They're part of my data lake, and I want to be able to track that as part of my overall, data in my lake. And then I see this coming up here. So you get all this metadata about your data, actually, like what format it's in, where we have stored it, how much data there is, the schema, also get nicely populated in here. And because we have this, we can read with different engines, because if we want to use like Athena goes here and sees, oh, this is what this data looks like. This is how I read this because it's in this format. But same for other query engines. If I now would use Redshift Spectrum or Data Warehouse, we can do the same thing. We can also read the same data there through SQL. So that's the amazing thing of having that data catalog, that you can have an overview of your data, but also be able to use that data with different query engines and not just, in your SQL database.
Wonderful. We have a question coming in from Paranoiac Zero. It's basically just a question about how you do this. Coming in, is your Spark job consuming events from MSK or managed something Kafka?
Yeah. I'm streaming for Apache Kafka. So I actually created a, let me see, set it up a while ago. So let me see. MSK cluster.
Okay.
And I actually, I don't have this. I didn't use a serverless one. I used just
The
an
expensive one.
instance one. But yeah, it's an MSK cluster that we're running
Yeah.
for my Kafka topic.
Okay. Yeah, we have fans of Kafka here. Ricardo in the chat. He apparently used to do something with Kafka. I don't know, but yeah. Okay, cool. Thank you so much. Now these tape like HUDI doesn't interact with Athena directly, right? So it creates these tables in a data catalog, right? And that's it, right?
Yeah. So actually, I have this here, right? So my data is coming from Kafka. Actually this tiny part here, I should have put EMR in it and Spark, because this arrow is being implemented in EMR with Spark, writing it to Amazon S3 in HUDI format. And then all the reading really happens through that catalog that just knows what is in my buckets, in my S3 buckets, and knows how to tell Athena, for example, how to read it, and other engines as well. So yeah, all goes through that catalog now for reads.
Okay, that's amazing. Cool. Yeah, Rishabh, welcome to the live stream. Welcome. We try to get folks on this stream as well, and we would like to kind of get you watching this. But very important on that point, I'm gonna just step back from the show for a second here. I want the audience here who's watching us and watching Shana do this magic. I want you to take some time. You don't have to do it immediately, but think about it. Give us some feedback. Tell us, do you like the show? Do you like this episode? Do you think the hosts are good? Is Shana doing an amazing job? Of course she is. And also, you can write in that little survey, what would you like to see on a future show?
Please
One of the things we're trying to do. Yeah, we're trying to actually tailor these shows to something you care about. So please let us know about that.
And we're kind of doing a lot of like content stuff right now too, like with planning around what's coming up, trying to figure out what topics people want to learn. So please absolutely fill this form out. I was like, I can't talk too much about data lakes, but I can talk about this form. So
so speaking of great stuff, Shana, now this all things we have it in an Amazon Athena thing, right? We have all of the data, we have the catalog, we can read it, optimize, we can write in a more optimized way. Can we have now? How do we actually solve problems with HUDI here? For example, you mentioned this in the beginning, modifying, deleting, doing something with individual records, right? Individual record level stuff. Can you show us an example of that? Because again, coming from Europe, GDPR is a big thing, and one of the big problems I've seen in the beginning is like, if we have a massive data lake, how do I delete things from that data lake, especially PII, personal identifiable information?
Yeah, totally. This is the wrong one. Sorry, let me pull up an example to show you that, because then we kind of have to go back, because that one I can easily show. Patient example. I'm just going to run a different notebook, so bear with me. This doesn't really matter. But yeah, let's say this is our patient data now, and I'm going to delete a single record, let's say. I have to wait for my Spark session to start. That's
okay.
A few seconds. But yeah, we'll look at this, right? So we shift gears again to the patient data, and I'm going to delete a single record in any case, right? A single patient. So I'm going to do that. Let me see, which one was it? The data deletion. Okay, so I have a Spark session now. Again, that's all I need. Let me actually read one patient. So I'm going to just do a SQL query of like, give me one patient record so I know kind of what I want to delete. And my kernel is still like half starting, it seems. So sorry if that's slow.
We're doing it live, so it's okay. It just takes a while, and EMR is not the fastest thing in the world, so
it's just showing the authentic experience.
Yeah. So this is a patient, fake data, in my data set. And if I now define my HUDI options, I won't deviate too much from the delete topic because I don't want to confuse you. But basically I can just do this. So this data frame that I just read, let me just check whether it's the right one. Yeah, so I read this one patient into a data frame called DF.
Okay.
And if I now just want to do a delete, I can actually just do this. I write it again in HUDI format, but I say, oh, as a write operation, you need to delete it. Don't upsert it, don't insert it, but delete this. And if I run this, it should delete. Now, this actually takes about 20 seconds, I think, in total.
Yeah.
And that is absolutely normal because in this use case, remember, I was not so worried with write performance or update performance because I
Of
have
course.
everything in Parquet and I don't really care about how fast that is. So I'm going to have like larger Parquet files, but that takes a little bit of time because I'm now updating one record, sorry, deleting one record,
Deleting.
and this is going to rewrite an entire Parquet file, which in my case is like almost 30 megabytes. It's not very large, but just a demo. So this succeeded, and you see it took 33 seconds. So because of this table type with this data format, it's a little bit slower, but
That's
that's
okay.
what we
But
chose.
what it's
And
doing right now, it's taking that big Parquet file and it's creating a
yeah,
new version of it with the record deleted, right?
yeah, exactly. So if I can now show you that it was actually deleted. If I look for this SSN that I just had here of no Tyson, if I search for it, well, let's hope it doesn't show up. Yeah, there you go.
Okay.
It's not available anymore. And if I show you, if I may, on the data, what has changed, see how this changed from 16 to 17? Should have called up 16 first. But anyway, if I filter on last modified data, you'll see that here we created actually a new Parquet file just for this one delete that we did.
Yeah. Yeah.
So
Okay.
that is,
So
yeah.
just for the audience here, the data is fake, and you can actually see that it's fake because it uses social security numbers, but it uses height in meters and the weight in kilograms. Just so you know, no feet or inches here. But but let me be the devil's advocate here for a second. If we have multiple versions of the file, would this data still be contained in an old version of the file?
True. Very good point, actually. So that is for GDPR compliance, something that you do need to take into account. So if you really have a requirement of, you are not allowed to have that data anymore,
Okay.
then I need to make sure that HUDI cleans up after itself. And that when HUDI creates this version, it actually deletes the previous version of this file, which is, if we look at the names, the prefix is the same. I think it's even this
Right.
one. Yeah, so this one. This is the previous version of that. It's a little tough to see. It doesn't, it's not so important, but then we need to tell HUDI like, oh, you need to clean up this at the same time. Once you've written this, delete this. And we can do that. But yeah,
Okay. Beautiful.
otherwise we can say, show me the table an hour ago and we will still have that deleted record.
And I wanted to ask you about that because you mentioned this, like it's metadata. We can see how the data changes. Can we have a look at like data an hour ago? Can you do that through HUDI? Can you show us like historical data or how it's changed?
I can. To do it on the
Maybe,
spot because it's not supported in Athena yet.
okay.
That type of query is not yet supported in like it's an incremental query. So I cannot just simply run it here. I could
That's
run
okay.
it
That's okay.
in
That's
Spark
okay.
and I could
I'm just wondering if it's
like
possible.
it is. So I could just like do here something like this. Do you have that? Sorry, no. Spark.read.format in HUDI. And then I would say I need to have an option that specifies that I want an incremental query. And I would need to look up the syntax for that because I don't know it off the top of my head. And then a load of my table path. So I could Google that quickly, but since we're like 8 minutes,
Can we first of all get some clap emojis for Shana here for live typing a Spark job?
I'm right.
Can
I'm
we
like
do
live
that?
demoing literally anything is stressful, and suddenly my
Yeah.
fingers are like, "What are keys? Don't know." Like, this
I
is
think it's
great.
okay if you don't know the syntax. Okay, so
Yeah.
you can technically do it. That's a good thing. And also, there's a comment here from Ricardo saying that you can always reprocess the Kafka topic. The immutable data is there, right? I guess. Um, I don't know what any of those words mean, but yes. um,
Yeah,
Awesome.
but that doesn't allow you to say, show me what my table looked like an hour ago.
Okay.
It just allows you to do another important thing, which is replaying. If something goes wrong, you can just
Hmm.
replay and start reading from Kafka again and like process all that stuff again.
Okay. Okay. Awesome. Awesome. Shana, I think personally, I learned a lot today. Actually, I've learned a few things, learned new words, learned some of the new concepts as well. And this is an open source tool, right? It's something that you can use wherever and whenever. So, kind of taking that position, how do people start using Hoodie? How do they get rolling with it, right? So, we have Chris in chat here and saying like, you know what? I just want to use Hoodie now for my power meters. How does one do that?
Yeah. So I would recommend, so just like to get familiar with the format and how you read and write, and then you're up and running, is to actually follow a workshop that we have. It's really like easy to digest content, takes you through like getting started with Hoodie step by step on AWS in this case. But I would suggest to start there because it gives you like that nice gradual overview, like gradually building up complexity. And then, you can roll up your sleeves, do it yourself. That is like
Yeah.
the best way to learn, I would say, rather than reading some documents. But we do
Is
also
it
have interesting blog posts on Hoodie.
Is it that transactional data lakes workshop you were talking about?
Yeah, that
Okay.
one. Highly
The links
recommend.
in the chat. The links in the chat. So do check it out, and also sharing another link for getting started with Hoodie as well.
Oh yeah, on
Um,
EMR, for example, that is also like
yeah,
the good content to get
yeah.
started. Yeah, not too much
But
tech,
basically,
the
yeah,
basic.
basically you have all of the elements you need to work with Hoodie on within your AWS account, right?
Yeah, totally. Hoodie is fully open source, so really, you just like you need EMR or Glue, and you can get started. Just on S3 like you do every day, and then you use Hoodie on top of that. Which is you're not paying for Hoodie,
Yeah.
you pay for
Could
EMR.
could I technically use Hoodie on my workstation at home, like outside of the cloud?
If you install, if you have Spark running, for example, then you can, or Flink,
Okay.
or any of the engines that Hoodie supports. But yeah, you'll need to have that because it does require any of like those underlying engines.
Yeah.
But you can.
Yeah.
You can also, I think there is even a Docker demo on the Hoodie documentation, the official
Okay.
Hoodie documentation. So then you can run it locally easily.
Excellent, excellent. I mean, it's an open source tool, so hey, that's
Yeah.
what you do. You can do stuff with. It's not necessarily tied to the cloud. And there's the link in the chat for Docker demo. So if you want to go check that out, it's just under my face or in the chat. Or if you're watching this on YouTube, hello for the future. I hope it's better. The link should be in the descriptions as well. One thing we want to also share with all of you there. So if chat, you've enjoyed the wonderful Shana here talk to you all about Apache HUDI and all of this data stuff that we learned today. Um, if you're coming to reInvent in Las Vegas in like a month or so, Shana actually has a session with a few other amazing folks. So if you want to go and check out this session, it's OPN 402 is the session. I don't think I have the link to the. Do I have the link? Let me see. To the actual registration page? I do not. But OPN 402 is the session code. OPN 402 is the session code. So go there, register, however they call it. Is it registration or just like reserving a seat? Check it out, and you get to listen to Shana and a few other folks. Who's also presenting with you there, Shana?
So I have with me Stefano, Hugo, Carlos, and Altaf. So we have a builder session. It's five
Yeah,
people, 5 tables, and you get to build with us. Hoodie on
yeah,
EMR. It's awesome. It's just hands-on stuff live with us.
good, awesome. Yeah, so check it out. If you're there on reInvent, that could be a really great opportunity for you to get some more Apache HUDI love, more, maybe something more even when it comes to EMR. Awesome. So do not forget to do that. Speaking of not forgetting to do a thing, chat. I've asked you something. Can you please let us know? Is the thing we're doing okay? Did you like today's episode? Did you enjoy watching Shana do her magic with Apache HUDI and data lakes? Did you enjoy Jackie and me looking dumbfounded,
Yeah, this is
realizing
like the
that
quietest I've ever been on a stream because I'm literally just sitting here like I am a sponge. I'm just absorbing as much as I can.
exactly. And Chuck 133 or L133. Yeah, we would love to have these streams more often. That they're good for people's work hours, but we're trying our best to kind of accommodate most people. If you missed these streams, by the way, there's actually a link you can go and check it out. It's a website. Hope you heard of it. It's called YouTube. We have a channel called Build on AWS where we actually put the recordings of all previous live streams, and you can actually check them out as well. I know it's more fun when you do this live like this. So yeah, but if you missed something, if you want to go back, if you want to find the show notes, the links, all that stuff, we put them on the videos there. So if you have not already, smash the like and subscribe button and put your comments in the chat saying what's your favorite data lake? I don't know. I know people should comment on YouTube, so I'm trying to get the people to comment. Awesome. Shana, is there something we've missed? Is there something we did not ask you? Something that you wish to have to share with us, or something that you felt like we didn't get to today?
No, I think I dumped a lot on you, so I'll spare you from like more. But yeah, I would say like please fill in the survey. Super nice to hear from everyone to whether it was useful or not. And then like
Yes.
come find us at reInvent, right? We'll have fun. We'll build things together. It will be great. So
Exactly.
I hope to see some faces there, and don't be shy. Don't be a stranger.
Yeah, if
Exactly.
you
Don't
see
be a
us here, come
stranger.
say hi.
Yeah, absolutely. And now, one more thing, Shana, before you leave. I know you're an Amazonian and all that stuff, and you're part of this entire team. But if you could change, money is not the question. Like, money is not an issue. If you can change, update, modify, add a service at AWS, what would it be?
CloudFormation.
Okay.
I don't
Just
know.
the general cloud formation.
Rolling back, when it starts rolling back, it's like, okay, better go out for 2 hours now when I launch something huge, and then it gets stuck in delete. And no, that's the only thing.
I agree. CloudFormation should definitely be faster at deploying and rolling back services.
Oh.
I will echo that a lot. So our friends from CloudFormation, listen to us. And
Yeah.
I know the reasoning why it's all that, but yeah. Hey, it's a good bit of feedback. Awesome. Shana, thank you so much for being part of this.
Thank you for having me again. Looking
It's
forward
a
to next
pleasure.
time.
Likewise. By the way, next week.
Yes, next week. Spooky. Oh, it's
Chat.
his camera.
Yes, chat, Twitch. Next week, 27th of October, because it's close to Halloween, we're having a spooky live stream. So Jackie's going to be right here next to me in the studio, and we're going to be wearing costumes. We're going to be all the fun stuff, and we're going to be talking to you about your spooky, scary, horror IT stories. So if you've ever taken production down,
or deleted it, maybe.
Yeah, or deleted it, maybe. Yeah. Oh, we're out of time. We have to go. Thank you all. Goodbye. See you next week.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.